Hello students, today we are going to learn about the basics of compressible flow. So before proceeding, I will like to show you the slides so that you can develop confidence that you will easily learn this concept or not. And at last, I will end up with an example, very good example to understand it better. Okay, so coming to the topic, see, uh, some prerequisites are there. The first thing is that compressible flow, concepts of compressible flow are applicable to compressible fluids, the fluids which can be compressed. For example, gases and vapors. By application of pressure, you can reduce their volume, and by reducing the pressure, you can increase their volume. Means the density of the fluid can change. Those are called as compressible fluids. Okay, so compressible flow concepts are applied on those. Okay. Second, you must keep in mind that if there is m mass of a gas or m mass of a compressible fluid, then the heat content del Q of it is given by mCp dt. M is the mass, Cp is the specific heat at constant pressure, dt is the change in temperature. Means in case you have some reference temperature, then how much higher from that reference temperature, that is the total heat content of the gas. Third thing you must keep in mind is that we know this thing that when sound propagates, then it propagates with some speed. Okay, so when sound propagates through some gas, then the speed of sound is given by small a, that is equals to root gamma RT. Here gamma is the ratio of specific heats of the gas, means Cp and Cv, specific heat at constant pressure, divided by specific heat at constant volume. Okay, R is the universal gas constant and T is the temperature in Kelvin. Okay, so this is the speed of sound in a gas. Next, you must keep in mind that if there is some gas and at a point where temperature is T, we know this thing gamma and R are constant, however T at different points can be different. So at a particular point, in case A is the velocity of sound, then if the gas is moving with velocity V at that point, then V divided by A, means velocity of gas upon velocity of sound at that point, is called as local Mach number. Means at that particular point, the Mach number is given by V by A. V is the velocity of gas at that point. A is the velocity of sound at that point of gas. And next, you must keep in mind that sudden density or pressure change of a gas is an adiabatic process. I think you all know what is adiabatic process. Adiabatic process is the one in which neither heat is given to the system nor heat is taken out. Okay. So in case some sudden changes are applied on a gas, means sudden the pressure is reduced or sudden the pressure is increased in a fraction of second, in milliseconds. Okay. In that case, it will be considered as an adiabatic process. Okay. So these things you must keep in mind before learning about compressible flow. So let's come to the topic. Suppose that this is a mass of gas, m is the mass. Okay, a lump of gas is there which is moving toward positive direction of x, and here there is a rigid wall. You can see there is a rigid wall. Okay, and the temperature, pressure and density of that mass of gas is Tp rho. Okay, and these are called as static properties. Means when the gas is moving, then the temperature, pressure, density are called as static properties. Means static temperature, static pressure or static density, like this. Okay, the gas is moving with velocity v. Now suppose it goes and strikes this rigid wall like this and stops. So what will happen? Earlier it had kinetic energy half mv square. Finally, when it will strike this wall, the whole kinetic energy will convert into heat energy and the mass of gas will completely stop. Okay, so when this moving gas is completely stopped, the kinetic energy will change into heat energy. At that time, whatever the temperature, pressure and density will be, those are called as stagnation properties. Okay, so at that point, when the gas is stopped completely and kinetic energy changes into heat energy, at that time the temperature, pressure and density will rise. Okay, so those are called as stagnation properties. Stagnation temperature, stagnation pressure, stagnation density. Okay, now since the kinetic energy has been changed into heat energy, and I already told the total heat content of a gas is given by m cpdt. So initial temperature was static temperature T, final temperature was stagnation temperature. Okay, so half mv square equals to mcp T naught by T. Okay, mcp T naught minus T. Okay, so we can cancel out this m, and ultimately T naught will be equals to how much? That will be, this Cp will go in the denominator in the left. Okay, so v square by 2 cp plus T. So this will be the stagnation temperature. of this mass. So in case I divide both the sides by T, I will get T naught by T equals to 1 plus V square by 2 CPT. So this is how we can find out the stagnation temperature of the gas. Furthermore, we know this thing that the difference of Cp and Cv is given by R. This is called as Mayer's relation. In thermodynamics, you would have learned. And Cp by Cv equals to gamma. So Cv can be written as what? Cp by gamma. Here I have written. Now, in this Mayer's relation, in case I put the value of Cv, I will get what? Cp minus Cp by gamma equals to R. So ultimately, I can take out Cp common. So 1 minus 1 by gamma equals to R. So ultimately, this gamma times R upon gamma minus 1. You can do this mathematics. Okay. Now, in case I keep this value of Cp at this point in this equation, in place of Cp, what I will get like this. In place of Cp, just I have kept this value gamma R upon gamma minus 1. Okay. So this now what changes can take place? This gamma minus 1 will go upstairs. So gamma minus 1 upon 2, and in the denominator gamma RT will be there, and in the numerator there will be V square like this. So this will be the change in the expression. Furthermore, we know this thing that root gamma RT is the velocity of sound A. So here it is, there is no root, so this will be the sound's velocity square, A square. So in place of this gamma RT, I can write, I have already told, A equals to root gamma RT. Okay, so V by A is Mach number. I already told this thing, Mach number or local Mach number. So in place of this V square by A square, I can write Mach number square. Okay, so what we see, the T naught by T, the stagnation temperature upon static temperature comes out to be 1 plus gamma minus 1 upon 2 into m square. So over here, this is interesting to know that m is a non-dimensional number because numerator and denominator both have same dimension. V and A both are actually velocities. Gamma is also non-dimensional number. Cp by Cv is gamma, so non-dimensional because Cp Cv both have same units, and similarly LHS also have a non-dimensional term T naught by T, both are temperatures. Okay, so what we see that stagnation temperature means when the moving fluid, moving gas is completely stopped, then the stagnation temperature mainly depends on the Mach number at the end. Ultimately, whatever the Mach number is. So in case we have the information of Mach number, because gamma is a constant, just we have the information of the Mach number and initial temperature, initial static temperature, we can find out the stagnation temperature. Now, how to find out the stagnation pressure and density? I already told that the sudden processes are always adiabatic. This is a sudden process, means a gas is suddenly stopped. Then we know this thing that for adiabatic process, the relation between temperature and pressure is this. This is general relation. T1 by P1 raised to power gamma minus 1 gamma equals to T2 by P2 raised to power gamma minus 1 gamma. So which will give what? In case I cross multiply, then P2 by P1 raised to power gamma minus 1 gamma equals to T2 by T1. So in case I remove the power of P2 by P1, then P2 by P1 will equals to T2 by T1 raised to power gamma upon gamma minus 1. Okay, so this will be the P2 by P1 for such relation. Okay, so in case in place of T2 I write T naught, then in place of P2 I will write P naught, and in place of T1 in case I write only T, that is the static temperature. In place of P1 also I will write P. Okay, so in case I put the value of T naught by T in this place, then I will get P naught by P. So P naught by P equals to 1 plus gamma minus 1 upon 2 m square raised to power gamma upon gamma minus 1. Okay, by this way we can find out the stagnation pressure. We have found the stagnation pressure formula. Now we will move toward the stagnation density. Okay, we know this thing that for adiabatic process, there is also one more relation. T1 V1 raised to power gamma minus 1 equals to T2 V2 raised to power gamma minus 1. Okay. But V1 is volume, and we know this thing that mass upon volume is density. So volume can be written as mass upon density. So M upon initial density rho 1, and for V2 also I can write m upon rho 2. So this m will be cancelled out to the power gamma minus 1. This will cancelled out. So ultimately we will get T1 by rho 1 raised to power gamma minus 1 equals to T2 by rho 2 gamma minus 1. So what I will get, T1 by T2 equals to rho 1 by rho 2 raised to power gamma minus 1. So in case I remove the power, then rho 1 by rho 2 equals to T1 by T2 raised to power 1 by gamma minus 1 in case I want to remove the power. So in case in place of T1 I write T naught, in place of T2 I write T, then in place of rho 1 I can write rho naught, and in place of rho 2 I can write only rho. So I will, so T naught by T is this. So in case putting inside this bracket, I will get rho naught by rho. So by this way, I will find the stagnation density. You can see I found the stagnation density formula also. Now, few more things. Suppose I say that the gas mass has struck this wall and stopped. So the final temperature and pressure and densities are this. These are stagnation properties. Now, suppose it rebounds. After striking, it rebounds back. So I am starting my experiment when it started rebounding. So in that case, what will happen? It will finally attain some velocity. Entire heat will convert into kinetic energy, and then the temperature, pressure, and density will become static. Okay, earlier stagnation, and when it starts moving, it becomes static. Okay, so this is a reverse process. Now I will take an example. Suppose I say this is a boiler. You can see water is boiling, so steam is forming. So inside this boiler, the steam is not moving. So when the steam is not moving, at that case, the temperature, pressure, density will be the stagnation temperature, stagnation pressure, and stagnation density. And gamma will be the Cp by Cv of the steam because it is not moving. So initially stagnation property. Now a nozzle is applied to accelerate the velocity of steam when it is coming out from the boiler. So I am taking this as a system. You can see this dashed box is the system of nozzle. So at any point I want to find out the temperature, pressure and density of the steam. Just I must have the information of M, because there are formulas we have already derived. These are the formulas I already told. So just by information of Mach number I can find out T in case I have the information of T naught, because gamma is constant. Gamma will not change. So just by the information of Mach number I can find T. Similarly I can find P also. I can find rho also. So this is one of a use of this concept. Okay, so by this small lecture you would have understood the basics of this compressible flow. Thank you.